Okay, so yeah, so this thing we have already we have already understood that, or rather we have already discussed that. So casting is many a time. So sometimes it does not require computation, but in general, casting will require some amount of computation. Okay, so casting is not, even though you know uh, it's provided by the code is provided by the compiler. Okay, but it is a thing that is, yeah, so it is an operation which needs to be, I mean, one needs to be careful about it. And so this C style casting we have seen, so I'm going to just skip. So, in order to sort of clarify this semantics that, there can be different types of casting and all that. Okay. C++ provides this cast operators, and it provides this 4 cast operators. Okay, and they kind of cover all types of casting. Okay, um, and yeah, yeah, so this is the idea, and basically the recommendation is that even though C style casting is also available in C++, but for simply for code clarity, you should use this C++ style cast operators. Underlying operation may be the same, but this will provide for much clearer understanding of the code. Okay, so we have seen one cast operator, which is the const cast operator. Okay. Okay, so this is basically so we have seen that all cast operators, the syntax is basically something like this, that you say const cast, then you provide the type, okay, and then you provide the expression that you are casting. Okay, and this is this is so basically this is assigned to the expression where you store the cast value. Okay. Yeah, so explicitly overrides const and or volatile in a cast. Okay, so this does not perform any computation. So this const cast operator is essentially to change the const or volatile status. Okay, so this does not perform any computation as such. Okay. Um, Okay, so let us see this. So this is kind of one use of the const cast operator that we have seen here. So we are seeing here rather. So even if you have this const cast star C, okay, uh, and you have this, you have this, let's say function which is the print function which takes char star and not const char star. Okay. So then if you call char C, then it will create an error because you are passing const char star where it should actually have a char star. Okay. But if you do this const cast char star C, then it works. Okay. Um, yeah. So similarly, if you have this class A, okay, and let's say you have uh, if you have a set member function which is not of type const, then as you know, you cannot call this set member function, right? Okay, but if you do if you do const cast a ampersand, okay, and then if you take a and then if you do a set, okay, this is allowed, but you cannot so const cast. So one thing is that const cast cannot cast object of of const type. So it can cast pointer or references of const type, but it cannot change the access specification of an object itself. Okay, so this one is not valid. If you say that const cast a, okay, and set 5, then this is not valid. Okay. So this is about the const cast operator. So not much. It is just a it is just a situation where you sort of reinterpret, or I would say you try to understand. I mean, you try to basically change the constness behavior of pointers or references. Okay, so this is how it should be understood. So from a semantics point of view, the const cast operator. Okay. Okay, so this is fine. Okay, so now so this slide. So by the way, any question till now? Okay, okay. So now we come to the second thing, which is kind of one of the most important operators, or at least the most frequently used operators. Okay, which is the static cast operators. Okay, so operator. Okay, so the static cast performs all conversions allowed implicitly and also opposite of those. Okay, so so definitely, if in C style casting, if you have something that is allowed implicitly, okay, that is the static cast operator. Okay, so for example, okay, so it can also convert, let's say, from void star to any pointer type. Okay, so this is a static cast operation. Okay, and it can convert integer, floating point values, and enum types to enum types. Okay, so this kind of conversion. So it can convert between, of course, integer to floating point to integer, etc. Okay, but also all the C style casting that you basically do, you can do using static cast. Okay, yeah. Okay, so so static cast can so static cast can perform conversions between pointers to related classes. Okay, um, uh, so it can perform upcasts. It can also perform downcasts. Okay, uh, okay, but the key here is that no checks are performed during runtime to guarantee that the object being converted is in fact a full object of the destination type. We will see this in greater detail when we look at the dynamic cast. Okay, but essentially you can perform these kind of casts. So we'll see each one by example. Okay. Okay. Additionally, static cast can also perform. So one of the things is it can explicitly call a single argument constructor or a conversion operator. So this kind of thing you can say is this is like a user defined cast. Okay. So this can also be done using static cast. Okay. Then yeah, convert to R value references. This we will not discuss R value references here. Okay, but there's something called R value references, so you can also do those kind of conversions. Okay, convert enum class values to integers and floating point values. So this is the opposite of the previous one, and convert any type to void, evaluating and discarding the value. Okay, so yeah, so so these are the things that a static cast can do. Okay, so let us look at some examples of what static cast can do. Okay, okay, so here it is like you have I as an integer, D as a double, and PD as a pointer. Okay, pointer to a double. Okay. Now you see in C you can do this I is equal to D. This is the implicit cast with warning. Okay. So you can use static cast to do this. Okay. And if you do static cast, as we have already seen, you will not get a warning because you are explicitly mentioning that you want to do a cast from double to integer. Okay. You can also do C style explicit cast here. Okay. D2I again you can do static cast. Okay, this will work. Okay. Now, if you try to do this kind of a implicit conversion, okay, I to PD, okay, so you are converting a pointer to integer. Okay, so if you try to do an implicit cast, it will give an error in C. Okay, yeah, but if you try to do a C style explicit casting, this is allowed. Okay, now this one static cast will give an error. Okay, so it does not allow you, static cast will not allow you to convert from pointer to integer. Okay. So this is the thing. Okay. Okay. Now, here we are talking about now this related, like a related thing. Okay. So what will happen? So if you yeah, so B is a subclass of A. Okay. Now you create an object and you created an object of type A and you created an object of type B. Okay. Now, if you create a pointer of type A and assign implicitly an object of type B, this is allowed in C++. We have seen this. Okay. Of course, you can do an explicit cast. Okay, this is also allowed, and static cast here is also allowed. Okay. Now, the other way, if you try to do, okay, if you try to, so this Q is actually a pointer of B star type. Okay, so it should be, I mean, you can just think here that Q, so there is a P star Q definition here. Okay, now if you try to assign, an object of type A to a pointer of type B star, okay, implicitly it will give an error because implicitly downcast is not allowed. Okay, but if you do an explicit cast, it will allow. Okay, now if you do a static cast, it will allow. Okay, so this is fine. Okay, but this is a source of a lot of error. Okay, so this actually should not be done. Okay, so what you should use here is dynamic cast, and we will see this when we discuss dynamic cast in a minute. Okay, but so here is the thing, that static cast, this will be allowed. Okay, but you should not really use this. Okay. Okay. Um, okay. So let us see that. So if you do a downcast, okay, or using the static cast, then what happens? Okay. So you see there is a window here. Okay. And you have used a virtual function on resize here. Okay. And then you have a special window, which is a subclass of window, and there, let's say, so what you are doing is you are again defining, you are basically sort of providing a re-implementation of this on resize function, which is also virtual here. So you are allowing somebody to create, other subclasses of this thing also. Okay. But yeah, so this is what it is. Okay. Now, so here, what you are doing is, so let's say, the thing is that the window provides some resize functionality. So first you want to utilize that resize functionality on the window class, and then you want to do the special window, you want to do something special. So there is some other window, special window specific things that you want to do. Okay. Now, what happens here actually, right? So you are doing a static cast window. Okay. And then you are providing star of this. Okay. Now, okay. So what happens is that this particular static cast, okay, it creates kind of a temporary object, okay, which is which is of type window, okay, and then it is calling a resize on that particular object, temporary object, okay. So what happens is actually, this is pointing to an object of type special window, right? But it has a sub object of type window, okay. So the static cast operator here will actually create that sub object of type window, okay, and then call a resize on that, okay. And then what will happen here is that actually your original object, which is of type special window, that on that this resize has not been called, okay. So this is kind of the the pitfall of so this is one pitfall of using this kind of static cast on objects. And then yeah, so this is just one example where you can understand that this so this kind of code doesn't work, okay. So what works is basically this we have already discussed. So you can do window : on resize, okay, and this will work perfectly, because you are qualifying that you are actually calling the function of the superclass, okay. Okay, so yeah, now now let us see when you try to so we were talking about this user defined casts, right? So let us see how how this works, okay. So let's say you want to basically cast from B to A or into A, okay. So then what you do, okay, so yeah, so here A and B are unrelated classes, okay. So you are defining A and B completely separately, okay. So so actually you need not pre-declare B also here, okay. You need not do a forward declaration here. So basically A and B are defined separately, okay. And then whatever you try to do here, you can try to convert from B to A, or you can try to convert from into A. All of them will give error because there is absolutely nothing, okay. So whether you try to do explicit cast, implicit cast, static cast, everything will give error, okay. Now you come here that you are now trying to define a user defined conversion method, okay. So how do you do? So one thing is that you can say that this is a constructor that you have created, okay, which basically takes takes an integer. And yeah, so this is one constructor. And then there is this another constructor, it's a kind of constructor, you can say, which takes basically a reference to B type object and creates an A type object. So this takes an int and create an A type object. This takes a reference to a B type object and creates A type object, okay. So now if you see here, okay, okay, so you can say that A is equal to B, okay. So this is an implicit conversion, okay. So this will work, okay. So this will basically use the use this particular constructor, where it will basically take a B, it'll take a B object here and construct a object out of it, okay. You can of course do this kind of explicit cast, which is also yeah, so you can think of it as a constructor, but it's really an explicit cast to type A. And this also uses this particular constructor. And similarly, you can do a static cast here. So and convert from B to A. Okay, so all this kind of user defined conversion is also allowed. Okay, similarly, this conversion from int. So a to I is allowed. Okay. Explicit cast is allowed and static cast is also allowed, and they call the same constructor. So this is like a you can say user defined user defined conversion between unrelated types. Okay. Now you can also do user defined conversion between unrelated type by using this I mean by overloading these static cast operators. Okay, so how does that work? Okay, so what you can see here is that okay, so yeah, so this is your usual constructor where you are saying the constructor takes basically an integer and does this. Okay, but you also provide this cast operator. Okay, so what is the cast operator? How do you provide the cast operator? So you say operator and then int and then open colon open bracket close bracket. Okay, so it is as though you are basically doing this the int function. Hello, can you hear me?
Yes, sir.
Yes, sir. Yes, sir.
Okay. How much did we lose? Is this 10 seconds? Okay. So you have understood the constructor way of providing user defined conversions, right? This particular slide 9 constructor way of providing user defined conversion.
Yes, sir. Yes, sir.
I have a doubt.
You had a doubt? Somebody had a doubt?
Yes, sir. Sir, what I wanted to ask is that when we do the statement A is equal to bracket A B on the right hand side sixth line in main function.
Yes.
Sir, here is copy assignment operator used like inbuilt copy assignment operator, or it just directly calls the constructor?
Here is copy assignment operator used. Okay.
Yes.
So yeah. So actually, what happens is see it will construct an object of type A from this object B. Okay. So and then it will be copied here. So yes. So this particular thing will be like an inbuilt copy of type A. Okay. So first there will be a construction of an object and then there will be a copy of type A.
Sir, does the same go for the above statement as well?
This one, the static.
Next one, static cast.
Yes. Static
Okay.
cast also will work in the similar manner.
Okay, sir.
Okay. So now okay. So now here we are trying to provide so we are trying to provide this same functionality using this our int operator. Okay, so int operator is basically what it is doing. It's it's providing a conversion mechanism from so it's providing a conversion mechanism from A to int. Okay. Yeah, so and here nothing is being done, but it's just simply printing things. Okay. And then it is returning the value. Okay. So what happens? So this one we have already seen. So you can okay. So there is another thing that now you are similarly. So just like you are providing this operator int here, okay, to convert from a to int. Similarly, you can also do for from B to A, you can provide the operator A. So here A is the type, here int was the type. Okay. So and then the same thing. Okay. So now you can do this conversion from B to A by simply saying and this particular operator will be called. Okay. In all three cases. Okay. Okay. So I hope the need for this is clear. Okay.
Sir, can you please once show the previous slide, sir?
Yes. So previous was yeah, this one.
Sir, on the right hand side also we are like doing A is equal to B, A is equal to static const A, static cast A, and the similar thing we are doing on the next slide. But in the next slide, like we are adding an operator function in B. So why is that need, sir? Like the work is done by the constructor in A itself only, no?
Right. So so first of all, so that's a good question. Okay. So why is so first of all, here you see here I had defined in the class a constructor which takes a reference
B.
from B. Okay. Here I have not defined that.
Yes, sir.
Okay. Instead, in class B, I am defining this operator A. Okay. Is the difference clear? I think maybe yeah, I should have put
Yes,
them.
sir. Yes, sir. Yes, sir.
So yeah, so that is the difference here. So you can, if you put a constructor here, okay, then so that is one way of doing it. Okay, but this is the other way of doing it, that you can do this. Okay. Okay. Now and similarly for integer also the similar thing is doing here. So here basically you are instead of doing the constructor way, you are going the conversion operator way. So you are redefining the conversion operator. So there are two ways of doing this conversion. One is you can define a constructor. Other is you can define a conversion operator. So conversion operator is not doing a construction of a new object. Okay, it's doing a yeah. So yeah, so it's doing a basically a conversion. Okay. So it so turns out that inside this conversion operator, again, you are sort of doing this this construction, but that is yeah. So that is a different thing. But yeah. So so theoretically, I mean, at least implementation wise, these are two different ways of doing it. Okay. Okay. Okay, so these are the some of the uses of static cast, and I mean how so what static cast can do basically. Okay, so static cast is basically the go-to cast operator. So as you can understand, basically all kinds of casting is being done using this particular static cast operator. Okay. Okay, let us go ahead to reinterpret cast. So reinterpret cast converts any pointer type to any other pointer type or even unrelated classes. Okay, so now reinterpret cast, you can think of it. So static cast, you have understood that it is basically doing some computation to actually do the conversion. So when you are doing a static cast from int to let's say double or something like that, or even if you are doing converting between two unrelated types, okay, it's providing that conversion code at the cast location. Okay, so it's so for built-in types, it's providing the compiler generated code. For your type, for user defined type, it is providing the either the constructor code or the cast operator that you have overloaded that particular code. Okay, so okay, so this is what static cast does. Okay, reinterpret cast again is simply a binary copy, so it can convert from any pointer type to any other pointer type or even unrelated classes. Okay, but the main thing is that there is no conversion code used here. Okay, so it is simply providing a binary copy of the value of one pointer to another. Okay. Okay, so all and in this case all pointer conversions are allowed. Neither the content pointed nor the pointer type itself is checked. Okay, so this is like the bitwise kind of conversion. Okay, so it can also cast pointers to or from integer types. Remember, this was not allowed. Okay, so this was not allowed in case of static cast, right? So you cannot static cast a pointer to an integer or yeah, so something like that, right? But this is allowed in case of reinterpret cast. Okay, but the thing is that the format in which the integer value integer value will be taken is platform specific. So there is no, so it can be it can be something like little India and big Indian. So there is no guarantee there. The only guarantee is that pointer cast to an integer type large enough to fully contain it, okay, is guaranteed to be able to cast back to a valid pointer. So you can copy to a integer a pointer, and then when you cast it back using reinterpret cast, okay, then you will get back the valid pointer. So that is guaranteed by this reinterpret cast. Okay. So these are conversions that can be performed by reinterpret cast, but not by static cast. Okay, are low-level operations based on reinterpreting the binary representations of the data. Okay, which on most cases results in code which is system specific and thus non-portable. Okay, but why you will use this is basically in some kind of a serialization setting. Okay, so if you want to, let's say, serialize a code or a object or something like that. Okay, you would want to basically put the you want to convert the different pointers like function pointers, void pointers, this, that, all these things into some integer format which is there as data. Okay, and then so then you are, let's say, sending it, either you are zipping it and sending it, or you are sending it over a network interface, or you are writing it to a file, whatever it is. Okay, later when you decode it back, you are guaranteed that you will get back the original object that you serialized in the first place. Okay, so this is the this is one of the uses of this reinterpret cast. Okay, so yeah, so you can do this. So if you remember, this pointer copying to integer was not allowed in static cast. This is allowed in reinterpret cast. Okay, because this is just a bitwise copy of the thing. Okay. And similarly, yeah, so pointer of one type can be cast using reinterpret cast to a pointer of another type. Okay, again, this is yeah, so this is also not allowed, right? Yeah. Okay, so any questions till now?
Sir,
Yes.
sir, in reinterpret cast, if you perform a bitwise copy of content, then we also have to guarantee that both the sides size is equal.
Both the sides size is equal or bigger.
Yes, means if let us say the object we are copying to a smaller size than the object we are copying from, then like there will be problems, right?
Yeah, there will be problem in when you try to recreate the original object, but reinterpret cast will not create any problem. It will just do a bit copy.
Okay, sir.
Okay. Now, okay, so now we come to the last topic, which is the dynamic cast. Okay. Okay. So, okay. So, what is dynamic cast? Okay. So, now, okay, so I will come to this slide later, maybe. Let me just see. Okay. Yeah. So, yeah. So okay. So first of all, dynamic cast can only be used with pointers and references to classes. Okay. So it yeah. So yeah. Okay. And its purpose is to ensure that the result of the type conversion points to a valid complete object of the destination pointer type. Okay. So yeah. Okay. So now this naturally includes a pointer upcast. Okay. So pointer upcast, is always valid. Okay. But you can also use dynamic cast to do it. Okay. Okay. Yeah. So in the same way that is allowed in implicit conversion. Okay. But dynamic cast can also downcast. Okay. Convert. Yeah, that is, pointer to base to pointer to derived. Okay. So downcast polymorphic classes if and only if the pointed object is a valid complete object of the target type. So this is the most crucial thing about dynamic cast. Okay. So this is the utility of dynamic cast, this particular thing that you can downcast. So you can also downcast, remember, using static cast. Okay. But with that, there is no guarantee that you have actually downcasted correctly. Okay. But here it will downcast only if the object is a valid object. Okay. Okay. Yeah. So if the pointed object is not a complete object of the target type, then dynamic cast returns a null pointer. Okay. So this is the other thing. Now, if dynamic cast is used to convert to a reference type and the conversion is not possible, okay, then an exception of type bad cast is thrown instead. Okay, so we will see exception handling next. Okay, but exceptions in C++. Okay, but just that. So the reason is here is that because references cannot be null. Okay, so the only way to let the program know that dynamic cast has been unsuccessful is to actually throw an exception. Okay. Okay, and dynamic cast can also perform other implicit casts allowed on pointers, such as casting of null pointers between pointer types. Okay, or casting any pointer to a void pointer type. Okay. So these are some of the utilities of dynamic cast. So let us look at some of the things here, what you can do. Okay. So suppose, you have this class A and then class B, which is a derived class of A, and then class C. Okay. So what you can do, you can first you can take here something like, so you have ABC objects of type A and then PA, PB and PC, which are pointers of type ABC. Okay. And also you can have void pointer PV. Okay. Now you are taking, let's say, PB, which is an object of type B. Okay. And you are trying to cast it. I mean, pointed to an object of type B. So this only works with pointers, of course. Okay. So you're trying to cast it to a pointer of type A. Okay. So this is valid. This is an upcast which is valid. Okay. So first one is valid. The second one, if you see here, it is again taking an object of type B, but in a pointer of type A, and then it is trying to do a downcast here. Okay, so it is doing a PA to PB. Okay, so PB is actually a derived class pointer. Okay, but the object that PA is pointing to is of type B. Okay, so this is also valid, a valid downcast. Okay, but if you change the object to type A, okay, sorry, if you change the object, yeah, to actually type A, okay, and which is also the pointer is in both cases type A, and then you try to do the same downcast, okay, then it is invalid. So it returns, basically you will see that it returns a null. Okay, so input was this, but it returns a null. Okay, so okay, so this is the key advantage that of this particular operator, that in runtime you can do so think about it now, right? So you think about your salary processing algorithm. Okay, so I will come to that. I think we have a example like that, or maybe not. So yeah, so basically, suppose you want to do something, some kind of an operation. Let's say you are having all employee pointers, okay, but you want to do some operation like which is specific to manager or something like that. Okay, so you can try to do a downcast and then check. If it is null, then you know that you cannot do operation on this one. Okay, otherwise you can do an operation. Okay, if it is not null, if it is returning a valid pointer, then you can do an operation. So dynamic cast ensures that your casting is actually valid. Okay. Okay. Now, so this is about yeah. So we have seen this invalid. Okay. Again, similarly, you have taken a type pointer, okay, and now you have pointed an object uh, of type C to this. Okay, so C style casting is of course valid. Okay, but if you try to do a dynamic cast here, it will still say unrelated cast, so invalid. Okay, so the other thing to know is that this dynamic cast can only check this kind of object validity if it is a cast on a hierarchy. Okay, but if it is not on a hierarchy, then it cannot. Even though this was actually an object of type C, it was not able to check here. Okay, so this is the other thing. Okay, and of course, if it is if you are giving input null pointer, okay, again unrelated cast, so it will give you a null pointer. Okay, uh, okay. Now if you try to cast it to void start type, okay, any pointer, this is valid. Okay, so this is valid. Okay, but you cannot cast from void start type to any pointer. Okay, so remember, all these are valid in static cast, but static cast does not ensure this object type integrity. Dynamic cast does. Okay, so but then this kind of conversions it cannot check. So all of these are basically error. Okay, so this one is will actually give an error if you try to pass a void pointer to dynamic cast. Okay, others will not give an error, but they will give a null pointer. Okay, so so I hope this is clear. Okay, okay, okay. Now we have so same kind of behavior. Is there a question? Okay, so we observe same kind of behavior here. Okay, that you can do something like okay, so you have ABC, and now you are doing this upcast here. Okay, so so a reference from B to reference from A, valid. Okay, you can do downcast here to an object, but the original object was pointing to an object of type B. So this is also valid. Okay. But now if your original object original A reference was pointing to an object of type A, then this is invalid. Okay. And you can actually print that. So you can just catch the exception and you can print that. Okay, we'll come to that in a minute. Okay, and also unrelated cast, as you know, is it cannot do dynamic cast, cannot do unrelated cast. So this is also invalid. Okay. Okay, so okay. Yeah, so one thing you note that so you observe that there is a difference. There's another difference between static cast and dynamic cast. Okay, basically, so dynamic cast also introduces some code to check this object consistency. Okay, which the static cast does not do. Okay. So you can say that whether the static cast will give an output or not give an output is known as at the compile time itself. Okay, so that is why you can relate to the name static cast, whereas this is dynamic cast. So this is not known, the kind of output depends on the actual object at runtime. Okay, so hence, yeah, so the output of the dynamic cast is not a compile error or something like that. It's a runtime error. Okay. Whereas in static cast, bad static cast can lead to runtime errors, but static cast itself will not give a runtime error. Okay. So this is the other difference between dynamic cast and static cast. Okay. Okay. So so now let us look at this. So something that is related. And it is related to basically this dynamic binding and polymorphism. And you can understand that this dynamic cast is also kind of related, or at least it is used, profitably in cases where you are actually utilizing this kind of dynamic binding, virtual functions, etc. Okay. Okay, so this is that type ID or that runtime type information that we were looking at. Okay, so the type ID operator is used. So it's an operator that C++ provides. Okay, it is used where the dynamic type of a polymorphic object must be known. Okay. Yeah, so first, yeah, so for for type identification. Okay. Okay, so type ID can be operator can be applied on a type or an expression. Okay, so similar to yeah, so yeah, you can do it on type also, but expression is the most I would say most common use case. Okay. Now, this type ID operator returns, returns an object of type std : type info. Okay, so this is an object which is which is defined in the standard library. Okay, and the major members of this object are the operator equal to and the operator not equal to. So these operator overloads for this particular type checks whether the objects refer to the same type or not. Okay, so if you take two type ID objects returned by, let's say, two different expressions, okay, two different variables or something. You can check whether their type is same or not. Okay, this is one thing. Other thing is you can also check the name of the type. Okay, so these are the two things you can do. Yeah. So the key thing is that this type ID operator works on a polymorphic type only. Okay, so it will if you don't again basically, as you can understand, this operator will output will be used only in case of runtime. I mean, so basically so I not at the compile time. So if you try to do a type ID on a non-polymorphic object, okay, then it will throw a bad type ID exception. Okay, so I hope this is clear. Okay, so here is some code. So you have created, let's say, a polymorphic hierarchy of class A and then derived class B. Okay, so what you can do here, you are just printing type ID of A, okay, which is an object of type A, and then you can also say address of A here, okay, and it will print class A and class A star. Okay, so the type of A is class A, and the type of ampersand A is class A star. Okay. Now you create a pointer of type A star and you put object A. Again, you can see that it will print class A star and class A if you try to take P and star of P. Okay. Now, if you take the subtype, okay, again, subtype B, and then you say that type ID of B, okay, and address of B. So it will say class B and class B star. Okay. Now, if you try to take this, if you try to assign this ampersand B to this P, which is of type A star, then type ID of P is class A star. Okay, you can understand this, that type ID of P is class A star, but type ID of star P is actually B. So it is doing a dynamic type identification here. Okay, similar to, how your something like your virtual function resolution was doing. Okay. Okay. And similarly with reference. Okay. So you can define two references and assign A and B to them. Okay. For the first one, it will say class A. Okay. For the second one, it will say class B, even though the reference type is actually A here. Okay. Okay. So I hope this is clear. Okay. And this is again the familiar staff salary processing architect, staff salary processing. And there, if you are trying to like print for each of the guys, so you have created a engineer, a manager, and a director. Okay, and then you can see that. Yeah, so you have engineer star stuff. Okay, so for all of these guys, and you've created an array. So all of these guys, the pointer type is engineer star, but the class of the object is actually engineer, manager, or director. Okay. Okay, so yeah, so now okay, so what happens when you call this type ID on a non-polymorphic hierarchy? Okay, so if you call type ID on a non-polymorphic hierarchy, so let's say you have basically class X and then class Y, which is a subclass of X, but now these are not polymorphic. Okay. So yeah, so you are creating object of type X, so everything is fine. Okay. You are creating pointer of type X, again everything is fine, output. Okay. So class X pointer type is X star, class for the pointer its type is X star, and the object type is X. Okay. Now if you create an object Y, okay, uh, again just like as expected, it will give a class Y and a class Y star. Okay. But now if you try to assign uh, a class X star to this so Q is a pointer to type X, class X. Okay. And you are trying to assign an object of type Y to Q. Okay. What will happen here is that it will say that this is X star and this is X. Okay. Even though if this was a polymorphic hierarchy, okay, if there were virtual functions in X here, okay, then this would have actually correctly identified that the object is of type Y. Okay. But here it is saying that the object is actually of type X, even though actually this pointer of type X is pointing to an object of type Y. Okay. Okay. And similarly with references also. So it fails to identify the dynamic type of the pointer or the reference if the hierarchy is not polymorphic. Okay. Okay. So this is the bad type ID exception. Okay. So yeah. So yeah. So if you yeah. So okay. Yeah. So in the yeah. So if you let's say if you do a delete, so the first one will work properly. Okay. For the second one, if you try to do a delete here, if you do a delete here actually, and then if you try to do a type ID, then it will say that yeah, actually in the in the first case, for the first cout, it will still correctly recognize because it is just printing the type of the pointer. Okay. But whenever you try to access the object again, actually it will yeah. So it will give a sort of it can also give a runtime error, something like a segmentation fault or something like that. Okay. So this will not work. Similarly, in case that the pointer is 0. Okay. Yeah. So in these cases, I mean, if if the pointer is not pointing to a valid object, then it will throw a bad type ID exception. Okay. Okay. So yeah. So just to I don't know how much time do I have. Okay, I'm already over time. Okay, so any questions on this casting or dynamic type conversion or anything? We are a little bit over time, but I don't know. Okay, so best of luck for your test. Okay, in the so you will have a test in the coming coming week. There are no classes because it's an exam week, and you'll have the test at the lab class slot. So I will give you the instructions about the test. Okay. Any questions regarding that or anything?
Sir, please try to upload the slides as soon as possible, sir.
I will upload the slides. Yes, I will upload the slides.
Thank you, sir.
Okay, then. Thank you very much. If you have any questions, you can just ping.
So once you repeat, please once you repeat the syllabus of the test.
Till whatever we taught today.
Okay.
Okay then. Okay. Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.